attendees. So
Okay.
we got record hit. So hi everybody, I'm Steve Lander, Director of Payment Management for WithersRavenel. And today's Lunch and Learn is automated data collection methods, pros and cons. So you have the pros here, not the cons. Yeah, just a little joke on the side there. Hope everybody's doing well. And the intent of our Lunch and Learn is to inform you of new practices. A lot of times it's practices and products for payment, but today we're going to be talking about payment condition surveys, which Eric and I could talk about for a really long time. So we'll definitely keep it to an hour. Obviously we're trying to broaden your knowledge of different ways of collecting data. All right, so today, if you need PDHs to keep up your PEs, we're giving out PDHs. So there'll be a link that Deanne will post in the chat. You just hit the link and it'll take you to a form, fill it out, and you'll get a PDH at the end. Other types of links to look for is one for the WithersRavenel website, the ARB's website, and then we'll have Eric Botting's email address along with mine if you need to get up with us. So these Lunch and Learns are recorded. And so if you have to walk away, we can send you the recording and you can still get your PDH. If folks in your office would like to see it, we can provide it. And also we can get you a copy of the presentation as well. And we always mention this at all our Lunch and Learns is if you have any ideas of things that you'd like for us to cover, just let us know. We know somebody in the industry who can help us out and deliver a good presentation. So the format of the Lunch and Learn is that Eric is going to be presenting for roughly 45 to 50 minutes, and he's laughing.
I thought we agreed it was going to be between 20 and 45.
Yeah.
Depending on questions.
So everybody's muted and no one else can see anybody else, but right now there's 16 people on. And so if you have questions, we want you to ask them while Eric is talking. We want this to be as much of a dialogue than just a presentation where Eric just kind of blows through his slides. So just put your questions into the chat. So I'm going to introduce Eric here. Man, it's like 40 years of experience. I was like, wow, it's like, and we've known each other for a long time. And so Eric has been in transportation for 18 years, and he's been with ARB for 9 years. So he has a vast career of collecting all types of data. And so I'm going to turn it over to Eric and he can tell us about it.
All right. Thank you for the introduction there, Steve. And thank you to everyone who's taken the time out of their day to log into this, and hopefully it'll be informative. Just want to start going through these slides here. Just a quick outline. I won't read them all, but the introduction, do that. Data collection, the title of this is the pros and cons of automated data collection, but I felt like, data collection is really in the center of a plan, right? So I wanted to kind of acknowledge that, and I'll get Steve to help me here in a few slides to talk about how we mesh together, I guess I'd say. And then the different types of platforms to collect data. I thought that was very important to identify those, and we can go over the pros and cons of each one of those, and then end with a conclusion. Well, I usually end with questions, but I marked it out to Steve's point. I really prefer this to be an interactive thing. So like you said, I've actually been doing this for quite a while. So it's hopefully between Steve and I will be prepared for any question that you can kind of come up with. So next slide is just a picture of me and my LinkedIn profile. It's Eric W. Botting if you want to go there. Let's see, in the last, I forget when that was, but I've gotten glasses and a lot more gray. So
Same.
Guess that's the same for everybody. Everybody uses a younger picture on LinkedIn, I think. But I'm in the Raleigh area. Um, Happy to meet with anybody online or in person. Just let me know. Um, Actually, before I get to that, just wanted to, like Steve said, I've been in transportation for 18 years, but I was actually in the utility industry for 23 years. So when I started my career, I actually, my brother said, "Hey, my bosses are hiring, and Atlanta's the place to be. You should move to Atlanta." I said, "Well, what am I going to do?" And they said, "Oh, we do mapping for utilities." Good time to switch there. So, my concern as a 21-year-old guy was, well, how do I pay for everything? And they're like, well, they pay for your lodging when you're gone. They pay for your meals, and I saw it as a way to get paid to travel. So I thought that was great. I took the job. And back in 1984 is simply called mapping. So the top left of your screen, you'll see an aerial photograph. Actually, it was a satellite. It's a satellite image now, but back in the day, when we were doing mapping and computers were just not involved, what they would do is our company worked with a aerial photograph company, so they would get all these quadrangle maps and they would come up with a flight plan and they would just fly back and forth, and then take those negatives, and we had a huge camera system. We had a guy that would do all the measurements so that we knew how to set the camera and it would be the perfect scale for the data collection. And I would take something similar to that top left image and something like the top right image, a template and 3 different colored pens. And they'd drop me off at the substation with an engineer. They would identify the phasing of the distribution lines coming out. If you can, actually, I just learned this today. Not the highlighter. Apologize. Laser pointer. So if you notice, there's 3 lines coming out. There are 3 main lines coming this way. There's another circuit this way, another circuit. You can see these, but there's another vertical one coming this way. But the point is, I would have something like this, and I would start and I would go literally pole by pole. I'd locate the pole. I'd do the inventory, do all of the basic connections. If there's a transformer, it's going to drop to a meter somewhere, get the meter number, everything would be on the map, take it back to the office from the field, put it under the Mylar sheets that we had done of the background, and we would draft onto the sheets. We would create blue lines. We would deliver the blue lines. We would also have reduced blue lines for people to keep in the back of their truck so that anytime that they made a modification of the system, they would simply redline the blue lines, and then once a year they'd send them in and they would get updated. So the bottom picture, I asked a friend of mine at a electric utility to send me the maps that they use now, and it's still the same thing. You got the lines, you got the poles. I probably could have done a little bit smaller scale. But the point of this whole story is that, what used to be called mapping here 40 plus years later is asset management, but we're basically doing the same thing, right, Steve? We're going out in the field, we're collecting important information on your system, and actually there was a little iteration there. Just when the computers finally did come on the scene, the first thing they did is they had computer aided drafting. They called that automated mapping. So instead of manual mapping, we're going automated mapping, and then the databases came along, and they would host the physical, inventory of what you had. And then people were like, well, until you can make the change in the map and it'll automatically change the database, I have no use for it. So then that was the automated mapping, facility management. You might have heard of AM/FM a long time ago. And GPS came along. Talk about automated mapping, being able to have a data logger with you and a positioning system with you. And then as those started getting, when GPS came along and the coordinates were special, a lot of mapping firms, when they put their maps together, they were all digitized at 0, 0. So you just had everything on top of each other. But the advantage of working at a mapping company was we understood GIS, and that's how we did all of our maps. So when we converted our automated maps to GIS, it just fit like a glove. So anyway, little story there, just to give you some perspective of my background and what I've got going on. So, the obligatory. I work for ARP Systems. They pay me, so they want me to put a slide or two on and let everybody know about them. We're really the roots. Our roots come from a company called ARB Group Incorporated, and the ARB stands for the Australian Road Research Board. And it's important, the research board, there's just a bunch of researchers. So back in the 60s, they got together and they did all the heavy lifting for the states in Australia and New Zealand. And then when the 80s, when the computers came along, everybody wanted to know about profilers, because that was a good way to measure their the roughness or smoothness of the road, which whether you're optimist or pessimist. And but what they did is, as researchers, every piece of data was important. So even though they might not have incorporated it into certain things, there was a place for it, and they had an understanding of what it was. So as a result, as the requests started coming in for, okay, so profilers are good, but now how do we integrate that within our current systems? So then they started developing IP for software, and then they did it so well that it became noticed on around the world. And then there's a development here in a little bit that I'll show, that once we brought that to the U.S., we started generating a lot of revenue. And they decided that they wanted to go back to be to their research roots. And so we kind of we restructured in 2017. Some of the longtime workers bought the IP and had the department, so we sell the equipment services. One thing, Steve, I forgot to update last night is we do have offices on every continent now. We have one in Brazil. So we have equipment, services, and offices all over the world. So this one in the middle is the one that I was talking about, but I'll start at the top because I think that's really the focus of this webinar, the pavement data collection. This is what we call a network survey vehicle. On the back, it has 3D lasers, 3D cameras. We use for automatic crack detection, and we also use it for the transverse profile for rutting. Over here we have some. I think this is the GPS. Oh, this is a camera. Situated with cameras. We also have a 3D camera system. And then the front is the digital laser profiler, which measures the roughness of your road. So basically what we did, ARP Systems is a systems integrator. And so we took all of the sensors off the van and we put it on this tractor trailer. And this is a traffic speed deflectometer. Not to be too simple or too expert, but deflections are used to collect the structural capacity, the structural health of a road. So what we wanted to do is we wanted to have a vehicle that in one pass could get all the surface distress information, get all of the deflections, the structural capacity, and then one thing that is not shown here is we also have a 3D GPR on it. So the idea is in one pass you can drive, you get continuous data. When you chart it up, it's real easy to see where things don't make sense, right? And it allows you a chance to go in and make a better decision on the health of your pavement. Because in the old days, if it was cracked really bad, well, then it's weak. And if it's smooth, then it's really strong. And that's obviously not the case. And then finally, the other integrated machine that we have here is what we call the Intelligent Safety Assessment Vehicle. And what that's doing is that's collecting continuous friction data. And then we have a rut bar on the front. So we're collecting the rutting. We're collecting the road geometry. And then we're also collecting texture and profile. And so the whole idea on that one is just because you have low texture doesn't mean you're going to have a lane departure. But if you have low texture or low friction, low texture, there's a lot of rutting and it's raining and it's coming out of a super curve. Now you have all the ingredients for a lane departure. So anyway, that's our intelligent safety assessment vehicle. So, most of these are state DOT level equipment, but since we have this van right here, we certainly do a lot of municipal work and support our friends like Steve. All right. So earlier when I was saying that, data collection is kind of in the middle of things, I started off as one of my favorite quotes. Failing to plan is planning to fail, right? So any data collection project, whether it's pavement or anything else, needs to have goals. It was funny. I was talking with Steve yesterday, joking that, I've been in this industry for a long time, and a lot of people want to come in and sell you on their data collection services, right? And that's what we're going to do for you, and we'll do it great, and it'll give you all the answers. But the people that I respect the most, like Steve, they're not selling pavement inspection surveys. They're talking about a plan to do life cycle modeling, right? So I thought it was important to put this slide in because what are your goals? If you just want to do a simple survey, so you can make a pretty map with good, fair, and poor, and you spend your budget until you run out, you do the worst first, spend your money, run out of money, you wait until your next budget comes along, then you spend all that money picking up where you left off last year until you run out of money that way. Then simple surveys are okay for you, but you know the next level up from that is actually doing some pavement management and actually taking some of this data and sharing it with your friends internally, because they have these software suites that they do pavement, they do assets, they do accounting, they do all these things. So even at the state DOT level, it's kind of funny. Well, kind of, I don't know how funny it is, but you spend a lot of money doing data collection for pavement management, and it goes to the headquarters to do pavement management, to do their government reporting and everything. But the local engineers don't ever look at it. They're just out there doing their own thing because the data that was collected for reporting purposes don't really help the practitioner in the field. And then, the step above that is, life cycle modeling, which is instead of just pavement management and doing that, you're just looking at it from a whole lot bigger picture. So it's to me that's important. As we go through this, the methodology of data collection is really going to dictate the end use of the data. But the bottom line is information. The more information allows you to do a better use of money. So that's where it falls in. Steve, I'll let you take this one.
Yep, this is me. And so what we like to do in each one of these things is talk about where it fits into the overall pavement management program or plan. And a lot of times there is no plan. And so, what kind of data do you need to collect? What do you have goals? Are you trying to reach some level of PCI? Do you know how much it's going to cost to get there? Do you know what kind of distress data that we need to collect? Are we collecting other assets while we're out in the field? So when we have a plan in place at the start, then everything else from this circle falls into place. And so various different types of pavement condition surveys and to use, and some of them make sense in some places and some of them don't make sense in other places, right? So trying to find the right one that's going to support, providing you the best data so you can make decisions from. After that, and I would have to say, if you're in a municipality with 50 or more miles, that life cycle modeling is going to be a really good thing for you. I'm going to use a tagline that an old boss used to say: when it comes to managing your network, do you know or are you guessing when it comes to how much money it takes to manage at a desired level of service? Do you even know what the level of service that you're trying to manage to, or are you just given a certain amount of money and you just do the best you can with what you have? So being able to know those types of things and letting the elected officials understand here's where we are with our pavement condition survey, and here's where we're going to be based on certain funding is really, really important. And then broadening the maintenance toolbox is so huge. You know, a lot of municipalities get into the mill and fill, and that's all they do. There's rejuvenators, there's microsurfacing, there's other products out there that we could extend the life of the road for less cost. The goal here is to manage at the highest level of service for the least cost, and then being able to take that information in the bid docs at the bottom of the circle, taking that information into the field, accurate bid documents, the construction inspection to make sure that it happens, and then construction history. It's so important. We really need to maintain some records of when we did things, who did the work, and then monitor how well they perform so that we can make adjustments as needed. And pavement doesn't exist in a vacuum, and to be able to model the other assets, your water, sewer, and stormwater with your pavement is really something that folks need to look at, you know, because I can make a statement that nobody likes a new cut on brand new asphalt. There's nobody, right? So, and then funding, which is very difficult to find for pavement, but we do for other assets. So these are the components of what we believe to be a successful pavement management program that needs to be looked at from year to year. But today we're talking about pavement condition surveys, so I'm going to turn it back over to Eric.
All right, thanks, Steve. One thing that I just want to add to that is, I kind of made the joke earlier about if you're just going worst to first from year to year. I mean, I get it. I've heard it 100 million times, and I've never been a government employee, but you can only do what you can do. But with that said, APWA has their annual conference, and if you look at their agenda, there's at least 2 or 3 courses every single year on how to get increased funding for your projects, right? If all you can do is tell your boss, well, good, fair, and poor, and we need more money, you know, think about when you were a kid and you asked your parents for more money. Well, what are you going to use it for? Well, to be better. Okay, but if you have, measurable, confirmable results that says, I need more money and this is why, and this is exactly how I'm going to use it, then you would be surprised at the amount of increase in funding that you get. Okay. So now what are we halfway in and we're just getting to, the title of what it is, pros and cons of automated data collection. I probably should have had Steve give me more detail, payment management, but I think it's a fair enough thing. But, and I put digital with this because I think that those are buzzwords that mean something a little bit different to everybody. So I just put the dictionary definition, right? Automated, made to operate by machines or computers in order to reduce the workload. Very simple. And then digital, I've seen hundreds of RFPs that come out that say, I want an automated survey. And that's all the information that they give you. And then, when you see that, that Steve hasn't been in to prep them on, you got to be a little more detailed to get what you want. But anyway, those are a couple of the buzzwords. So, going back to the very beginning, this is a colleague of mine. He worked at Texas DOT or the Texas Highway Department, I guess, back in the 80s. But they have lane closures. And, I was thinking about this, Steve. I think this is actually from the LTPP, the Long-Term Pavement Preservation Program, which is why they had the lane closures. But certainly I don't, that's some intense detail that I don't think normal people would do on that. So methods of pavement inspection, what I did is, I thought I would apologize for that. I thought I had taken those out. So these are, anyway, these are ranked from low tech to high tech. I'll just leave it at that. So coming in from the very beginning, let's see if I can, just want to get rid of that red dot. There we go. Okay, so when you're looking at the pros and cons from changing from manual to automated, you'll notice a a trend here where the pros are efficiency and speed, accuracy, reduced errors, consistency, and it's cost effective, right? So you think about, you think about, did that guy, is that a 4 or a 9? Steve, is this a 2 or is this a 1? So, certainly adding the automated portion of it reduces the errors. I just have a couple of, there's a tough book. You can take the tough book out and walk around with it. Or, there's a lot of systems that are set up to have the radar in the front seat and you can do a windshield survey, whether you're driving or you're off on the side of the road. But certainly there's one con that I left off of this, but the complex implementation is, and I've seen it and I've done it before, right? It's like, well, we want to be automated. Hey, I'm really good at Excel. Give me a tough book. I'll make sure that, there's the twos are the twos, the fours are the fours. I'll make a drop down menu. Um, and then what happens is the first hour you're out in the field, you're missing something on the drop down box. So what, do you go back to the office or do you make a notation of it? How do you fix it? Limited flexibility. And then of course, your piece of paper might have been blown away as a system failure, but you know, what you're opening yourself to with technology in the field by people that may or may not be qualified to do that is, you know, hey, I got the blue screen of death now. What do I do? Well, we've got to get a new computer. It's going to take a week. We'll go back out there. But anyway, biggest con from going from manual to automated is the score that you had manual is not going to be, typically it's not going to match what your automated results are. So to me, that throws up a lot of roadblocks in the very beginning, making this transition. And actually, there's a couple of state DOTs that have just changed from what's essentially a windshield survey to a more automated survey. But that's a big con. That's what stops a lot of people from automating what they're doing. Because, holy cow, we've been rating everything as a 75, and we did this automated survey, and now it's a 60. What am I going to tell? What am I going to tell my superiors? Well, that gets back to the plan, right? That you got to have a plan, right? We assume that these things are going to happen, and we're going to be ready to address it.
Hey, so Eric, what we tell our clients is if you're good with the rating methodology that you're using and you've been using it for multiple pavement condition surveys, it may make sense to stay with that type of survey just so you don't have a bump in your data from, like you said, from a 75 to a 60 where everything gets moved down. But if you're trying to collect other data, then it might make sense. So that's something at the planning stage that you talk about.
Yeah, good point there. The other thing is, the advantage. I heard this story when I first started working, when it was still the Australian Road Research Board, is that they actually did studies that if you get up on a Monday morning and there was chaos in your household all weekend and it's a gloomy day, you're going to go out and your ratings are going to be less than they would be on the exact same street if you got up on a Friday morning of a long weekend. You were going on vacation. It was sunny. It wasn't too hot. It wasn't too cold. Psychologically, you're going to actually rate that road differently than you would, and then you add in garbage, right? So if there's leaves and trash, again, psychologically, you're going to rate it lower than you would if it was free of debris. So that's automated to manual. So the next technology jump would be automated with a cell phone, and these are relatively new relatively new. I'm talking after 40 years, they're relatively new. So these came around probably 4 or 5 years ago. But again, the pros of this is its efficiency and speed, certainly safer than pulling off the side of the road or walking on the side of the road or doing 20 and a 50 to make sure that what type of crack was that. The scalability is also pretty good, right? It's hey, if one works and you're good with it, hey, let's just get 5 more and we'll have our stuff knocked out in no time. And it can be pretty cost effective. The point I'd love to make is well, let me go through the cons, right? So lack of distress classifications, right? What they're going to get is they're going to rate something based on the images, and they're going to use AI, which again, AI, the buzzword, what does it mean? What's the difference between AI and machine learning? It's, to me, I guess it's kind of like the cutting edge versus the bleeding edge, right? Well, you don't want to bleed out, so you just want to be on the cutting edge, but the chance for hurting yourself is certainly a lot higher the closer you get to the cutting edge. But so it'll attempt to tell you, and they might even call it a PCI. But again, it gets back to that planning. So what is your definition of PCI, right? If they're just telling you, well, hey, we figured the worst parts on your system were 100 or a 5, and the best was a 1, then everything else just kind of fit in between there. So you're limited on what you can do further down the workflow as far as how you can use this into payment management. Um, Also, a little bit of a vendor lock-in because the the fees to get into this is, well, you can either use their software, or you can use their phone, or you can use both, but you're going to pay a monthly fee. And then, of course, you have to process the data, so that costs a little bit. And then they're going to host it for you, and that's where you get locked in because one cell phone provider and the other cell phone provider are really not going to be a one-to-one match. And the cost of the sensor is about $1,000, right? Um, so you think about what's being used. Number one, the camera. Your the how many pixels you're going to get, and then the other thing is I'd like to joke about is the location accuracy. Anybody that has been waiting for an Uber and have been watching it as it gets there, sometimes your little blue dot goes across the street and swings around and comes back, and that's just based on the GPS sensor in there. So anyway, a couple of examples there, one inside, one outside. But it's better than nothing. It certainly gets you a little bit further than just putting it in a spreadsheet. But that's the next tech up from manual.
Hey, so Eric, when there isn't a human involved with the AI that collects payment condition data, there's usually going to be problems. That's the way it is right now.
Yeah, thanks for bringing that up, Steve. The thing that I tell people is, AI can be overtrained or it can be undertrained, and it just seems like in the rush to say, well, we're AI. What another buzzword? What does it really mean? How are they going about doing the AI? Are they really talking about machine learning? At ARB Systems, our development team prefers to do machine learning because they're giving them actual data that we've collected and trying to train it to say, okay, this means this means this. I think, is based on making some assumptions. You know, every year it's only going to get better. But anyway, that's where it is today. I'm just trying not to make this commercial. I'm trying to make it more of an educational thing. So anyway, the next step up on the technology scale is LiDAR. I don't know if how many people have heard of LiDAR, what it means. It's uh, light distance and reflectivity, right? It measures all those things. It creates a point cloud. So again, the pros, what does that mean? Well, the efficiency is even better. You can go just as fast. Its accuracy, reduced errors because it's just collecting the same stuff. And hey, when I got into transportation 18 years ago, LiDAR was, it was the beat all cure all. It was the best thing coming. It'll tell a utility pole. It can calculate the tree if it's going to fall in the right of way, retroreflectivity. It'll cut your grass if you get that, extension included. But here we are 18 years later, and what used to be maybe 2 companies that had LiDAR systems, now there's a dozen. And then, of course, that brings along the software developers that said, well, I can do something better than that, right? So, can they get cracks? Yes. Can they get depressions? Yes. Can they get rutting? Sure, they can. And then the other thing that makes it a little bit nicer is the ability to extract assets. if you want to get a hydrant, if you want to do these things, well, that's all in the point cloud. So, the key is finding out either how, again, coming back to automated, how much of this is automated? Will it give me 100% of my guardrail? Maybe. But, to Steve's point, it comes back to you want a little bit of human interaction just to make sure that doing some data quality checks. So the cons of it, complex implementation. I mean, it looks easy enough. The one on the left, you know, that's pretty much going to be the way it is. The one on the right, they say you can take it off every night. I don't know. It's seems a little bit complicated. Again, you can't determine the classifications of the distresses. You're talking about a system failure on this, man. You're really dead in the water. And then as you start getting up, I mean, all of them are weather dependent. Even the manual distresses, nobody wants to get wet. It's harder to see when the pavement's wet, but when you start adding lidar, I mean, it's just going to be bouncing around. You're not going to get very good results. And then again, like the cell phones, it's the vendor lock-in, each one of these and every other one. Well, we can rent it to you or we can collect it for you, and then you're going to pay to process. And then once it's in their system, then it's a little bit harder to kind of move between, well, from this vendor and this vendor. So, in my mind anyway, that's a con. Drones, pros and cons of drones, speed and efficiency, of course. The drone on the left is just a camera. So you can locate stuff, right? But again, it takes software, it takes human interaction to go in and extract these things, and you can still do it. It's cool, right? And it's safer because you're not in the right of way. Frankly, I was telling Steve this offline earlier. The people that I follow in the transportation industry with drones is WithersRavenel. You guys are always at the conferences that I go to. You bring the drone, a couple of guys, and I always ask them, where are we at with it? And of course, there's part of the cons is right now you have to have special permits to fly it. Number one, so that's something. Not everybody has that. The other thing too is you need a permit to be over a right of way and to be over the public, right? So that's kind of, how productive can you be? And on down, talk about system failure. Hopefully it just comes back to base instead of falling upside down. Weather dependent, of course, and then there's the battery life. So promising technology, but until we start ignoring the drones in the sky, just like we do airplanes now, I think that there's a lot of work left for that, personally. Let's see if
I always tell them to send me your best picture, and when they do, and you can't see the surface defects,
yeah,
the oxidation, the ravel, you can't see it.
yeah. So again, as as it matures, I mean, hey, if you could have a drone flying behind traffic at a lower level, so you can get those defects. Maybe that's the way. Maybe you put a better camera on it, and the one on the right has lidar. So then that brings all of the advantages that lidar brings to it, which is a certain amount of automation for feature extraction that you're trying to get to. And then finally, at the top of the food chain, and the picture is so big and detailed, I put it on the next one. But this is where we're talking about the our network survey vehicles, right? Where you have all this equipment. So the pros of our stuff is pretty solid, right? It's quantitative, it's defendable. We follow ASTM and AASHTO standards, so it's very repeatable. It's measurable. It's accurate. Every morning, if you do a phone survey, what you do is you put the phone on the vehicle, or on a suction cup. Well, what happens if you have, I drive a lot of rental cars, so there's a sports suspension, there's a cruising suspension, and all those things affect the vibration, and the accelerometer that goes with it. So again, cell phones are better than nothing, but when compared to the top of the food chain, there's no way to do any comparison with either your neighbor or internally. I've got a different system and I've got an 85. Okay, what does that mean? I got a 90. How does it? Well, they're different scales. It's hard to correlate the two. But when you're talking about this equipment, I mean, we do bounce tests every day. And a lot of things that are going behind the scenes. Again, I'll get back to the RFPs. I see a lot of RFPs that just say, yeah, we want an automated data collection. And then it might throw in a spec that means that they're looking for this, but there's absolutely no QC that goes along with it. Some of the best RFPs that I've seen that I know that Steve has influenced states, there's the number one, we want to see your data quality management program, number one. And if it doesn't include that before you collect any data, you're going to collect some, validation data on a point within our system, you're going to run it 5 times and you're going to show us that it's repeatable, it correlates to itself. Okay, now go collect data. And then, depending on the level of, because it also costs money, but I think that that's well worth it. We typically, some of our projects, they require it weekly to run the same things 5 times and to submit that information to show that the system is still operating the way that it's intended to. And then others say one at the beginning, one at the end, which, to me, if you wait that long, then you just lost all the advantages you have of doing this. So we typically try to do it once a month on large projects. But anyway.
We got a question on drones, or it
Okay.
says you mentioned permits required for drones flying over right away. Can you expand on the permits required for this? It was my understanding that you need a remote pilot's license to fly and follow the rules provided by FAA to collect that data.
Okay, so yeah, starting at the very beginning. So so they changed it. I have not followed this much in the last 3 years because we've just gotten so busy. But I've got a drone. In the beginning, you did have to have you had to have flight time. You had to have all these certifications and whatnot. But they've changed the permitting. And then, of course, there's the recreational people that you see out in the parks, and they're just taking pictures. But then you have the people that are actually generating revenue from it. So they're held to a higher standard, right? So you can't just take your drone over the state fair here at the fairgrounds from a few months ago, because if you lose control and it falls down and it hurts somebody, well, then they're just going to pick up the drone. They're going to get the number, and you should be registered in a database somewhere. So it's my understanding now that to be over people or traffic, you have to submit and get a permit that allows you to do that. Um, the surveys that I've seen done or the surveys that have tried to happen, what they do is they calculate an offset from the road, right? So they're not over the road in the public right of way per se, or in the pavement area. They're offset, and they're using high res cameras or lidar to get that information. But as far as flying over a road with traffic, it's my understanding that that's against the law right there. Hopefully that answered the question.
I don't know if they're typing. Yep.
Okay.
Got it.
All right. Good deal. So to get back to the pros and cons of this screen, so the ASTM and AASHTO standards, we follow dozens of those. It's just a way to make sure that hey, you're being held to to a standard and to be accountable. So the cons on some of the semi-automated fully. Well, I'll get into that when I switch to the picture. So the cons of the perception is it's costly. Eric, you just said that, gee, every month you have to spend a half a day going over and making sure that everything works okay. That's costly. Well, that's part of what we do. It's not the The true cost is getting actually to where the data collection is going to happen. Just driving over it really doesn't, cost that much. It's getting there and being there. And not just ARB systems, but every other vendor that's just part of business these days. So it's not as costly as you think. Maybe if you want to buy a van, I've had some municipals that want to buy a van, and I'm like, okay, how big is your system? And it's like, okay, so how do you justify spending $1 million on this equipment? And you're going to use it for 2 months, and every day your constituents walk in and say, well, what do we have $1 million sitting in the parking lot for? We're not using it. So, it's when you get a vendor involved, you know, we just come in, we knock it out. We prefer to work with, people like Steve that can take the data and give you good results from it. The overkill, that's the same thing. Do we need standards? If I was one on the line with my butt on the line, I would want to make sure that, hey, I was referencing at least some standard. Expertise, you just can't get in and drive. We have a training program for our drivers. It's very important to keep a straight line, and you don't want to wander too far out because that's going to, skew your results. And then limited vendors, there's less than a handful of people that do this at the state level here, and then about the same amount that are in the municipal market space. So, but it's competitive enough that it's to me it makes sense. One thing I wanted to point out before I switch from this screen is the integration of GIS and asset management systems. I mean, very detailed information that can be passed to these systems. I'm not saying that a phone platform that creates a spreadsheet of your cracks, that certainly can be put into GIS and asset management system, but it's just going to say, well, here's a crack and it's really bad. Whereas if you get into a program, doing life cycle modeling, it's going to say, well, this is an environmental crack, right? Versus a construction crack, like you said. Who wants to see a fresh cut on fresh pavement? Nobody. But that's a different deduct value. And then there's materials, and then there's other different ways to classify these distresses. So before I forget, the semi versus automated, right? So been a lot of development. All of these sensors, I think, have been widely accepted around the world for decades, right? The profiler, the positioning systems, the cameras, they're a calibrated camera, so you can do asset extraction from that. The laser crack measurement system. So the difference between semi-automated and automated is if you want to do a true D6433 inventory, there are certain things that the LCMS2 just won't pick up. And then the debate starts, right? Well, that distress, I hardly ever see it. And what's the deduct value of that? And so, if you can decide on I guess it's about, I don't know, 18, 20 things that can be truly automated from D6433, well, then it's just a push of the button. But if you want to get every single distress in D6433, then you've got somebody in an office that are going frame by frame by frame to pick up things like, I don't know. You tell me, Steve. Is it we had a conversation a while back? Was it oxidation? Right. I mean, as soon as you pave it, it's starting to oxidize.
Right.
How do you capture that? So, what has recently been done to get around these things is an ASTM standard E3303 is a totally automated, and what it does is it looks for a percent cracking in each frame. So if you want to do monitoring from year to year, it's very easy to compare the two. You can do it visually, you can do it through databases. And E3303 is designed to do that, because if I follow it and the other vendor follows it, and then now all of a sudden you're not locked into a vendor, and you can, start bidding this stuff out and go to competitive bid instead of, well, I've been using this company and their cell phone for the last 2 years. I mean, I think I'm just going to stick with that. But if you can get to this level, then it's just so much better.
Hey, Ken Holton's got a question. Would you describe what the daily bump test is doing? Calibration, etc. Sounds like this is really important.
It is. Thanks, Ken. That's a good question. So the bounce test is basically so the inertial profiler shown on the front of our vehicle. They're made up of, and that's how the cell phones do it, is because they have an accelerometer. The only difference is our accelerometer is thousands of dollars as opposed to $1,000, right? So there's anywhere from 2 to 3, or generally, and even more than that. Um, so in the beginning, what you do is you're getting that suspension. Earlier, I talked about the sporty suspension, the rough suspension, the whatever off-road suspension. These vans just have their suspension, right? So the bounce test is actually what they do is it starts out and it measures the distance from the laser to the pavement. Okay, that's what it is. Okay, so now let's put a bounce to it. So you put a little block under it, a known value, a millimeter or whatever, centimeter, and then you bounce the vehicle. And then when it stops, you measure it with the block to make sure that those measurements are still accurate. So those are done every day, and it's to test the accelerometers accelerometers and lasers are working together. An important thing I might have left out. So this system, as you see, the back especially, they're relying on 3D cameras and 3D LiDAR lasers, basically. And that's the difference from the LiDAR system, because they have the LiDAR is 3D, but the camera is 2D. So they're trying to augment, the results. And then the cell phone is just a 2D. It has no 3D capabilities to that yet. Actually, I could be probably proven wrong on that, because I think that some people are doing some sidewalk surveys with the LiDAR option on a cell phone, right? You just put it down and it measures a small area and it gives you the things. But anyway, uh, getting close on time.
We
So
are
let me get
close.
to my summary and conclusions.
Nice.
Bottom line is, I must have let me hold this. Manual rating, it's got slowly going away. Okay. There are many automated solutions. You just need to know what that automated means and how you're going to use that data down the road. If you don't have the different distresses, the environmental, construction stuff and whatnot, you're going to be limited on what you can do with these pavement management systems, because it's just going to say there's a crack there. Probably don't need to say this, but good data should always be a priority. Not all inspection vans are the same. I've seen a lot of vans that look like ours that don't have, the only thing that's got on it is a keyboard in the front. And it's funny to see these jockeys, they have all these shortcuts, for fatigue cracking, or anyway. It's automated, but to me, it's, on the low end of the tech scheme. And the bottom line, I think the drones are just better off for parking lots. If that's what you're trying to do, based on the limited battery time and the restrictions of being over people. Um, anyway, perfect for that. Those are my opinions, my conclusions. I love discussions. Like Steve said in the beginning, we could sit down at a conference and probably talk about this stuff for hours. So anyway, that's all I got. Steve, is if there's anything I left off that we've talked about previously, feel free to bring it up. And other than that, I'll let you take it home.
Yeah, I don't see any other questions, so I guess we could take it home. I'm gonna steal the screen here so you can see the person, one of the people who's going to be. Let's see. Is everybody? You see my screen?
Yes.
Okay. So, well, anyway, we'd like to thank everybody for attending today, and Eric, great job on your presentation. So next month. And is it hard to believe that we're at the end of February? I mean, what happened to January, right? So the next Lunch and Learn is going to be on Charleston County, South Carolina's TI program. Mackenzie Kelly, who you see here, who is dressed up as a pothole for for Halloween. She'll be one of the presenters, as will Ken Holton with Pavement Technology. So our next Lunch and Learn is Wednesday, March 26th at 11:30 a.m. And if for some reason you joined us today and you don't get the emails from us, you can email me and I'll put you on the list to make sure that you get the emails as they come out, and we're not going to bug you. So anyway, Eric, thanks for a great presentation, and thank you everybody for attending, and have a great rest of your day.
You're welcome, Steve, and thanks for the opportunity.
Take care, everybody.